Anchors and anchoring for small vessels under 100 ton is presented by John Beasley at Canada Point Maritime School. Start with the weight of your boat, then add the weight of fuel and water. Obtain an anchor load calculation chart and determine the wind force on the boat at 15, 30, 45 knots or at 20, 40, 60 knots. You can go with 2 larger anchors and leave out the lunch anchor. Add current and wave height to the wind load calculations. Select anchor types that work well in your area. Then design an anchor system with the anchor holding ability being the weak link, or most likely point of failure. All other components in the anchor system should have a safe working load margin above the anchor breakout load. Finally, buy a pair anchor for heaving to, and a drogue to slow the boat down and to steer the boat in the event of rudder failure. As we design an anchoring system, we begin with the design weight of the boat, at fuel 7.2 pounds per gallon and water at 8 pounds per gallon. Find the design weight of your boat in the owner's manual and add the weight of fuel and water. We are using the calculations for a 25-foot boat. If we wanted to be on the safe side, we could use the calculations for the 30-foot boats or use the calculations for 30 knots, 42 knots and 60 knots. Just for perspective, look at the force on the anchor system at 120 knots. Beaufort scale is often used in weather broadcasts when referring to wind speed and anchor holding ability. It is worthwhile to print a Beaufort chart off the internet, have it laminated and carry it on your boat. We can also calculate loads on our own from a table or mathematical formula. Take the height of the bow above the water line, 8 feet for this example, times the beam of the boat, which is 8 feet times 8 feet equals 64 square feet. To that figure we add 3/4 of that amount for windage on the superstructure, canvas and rigging. Wind load on the hull is calculated as 64 times 1.75 equals 112 pounds per square foot. In 20 knots we have a load of 141 pounds. In 30 knots we have a load of 336 pounds. In 40 knots we have a load of 556 pounds. To these numbers, you would adjust for the temperature of the wind, wave surge, and currents. The objective is to choose anchors that have a holding power greater than the minimum required for each anchor type. Lunch equals 125 pounds, working anchor equals 490, and storm anchor equals 980 pounds. To be safe, I use the lowest load holding power, which is soft mud, for each size anchor holding ability. The lunch anchor and working anchor could be FX11 to FX16, while the storm anchor could be an FX23 to FX37. The FX37 is rated super high holding power. Some people will design a 3-anchor system if they do much offshore work. Other boats can get by with a 2-anchor system. In the case of only using 2 anchors, they would design a working anchor and a storm anchor and leave off the lunch anchor. It is not smart to have only 1 anchor in a boat, in case it gets snagged or has to be cut free. The calculations in these charts assume average seas, semi-protected waters, and moderate temperature. In cold winds and high seas, the load forces exerted on the anchor system can double. Usually the maximum load exerted on the boat is the weight of the boat. In cold weather and high seas, the load can double. Wave surge at the top of the wave can double the load forces on the anchor system. Current is not a major factor, increasing the load by a few hundred pounds. Wind load increases quadratically with wind speed. The wind force at 60 knots is 4 times stronger than at 30 knots. The maximum wind load pressure exerted on the hull is likely to be the weight of the hull. Cold air is more dense than warm air and exerts more force on the hull. Ideally, the storm anchoring system would support the entire load of the boat's weight without creating other stability problems. The weight of the anchoring system needs to have as little impact as possible on the boat's center of buoyancy. Super high holding power anchors improve the sizes of storm anchors that can realistically be carried on small boats. In anchoring situations we are most concerned with pitching, heaving and surging. With a drogue we are concerned with yawing, broaching, surging, surfing, and pitching, rocking and diving under waves. There are many sources for anchor holding specifications. Probably the most comprehensive single source is Hint's Complete Book of Anchoring. Anchors are rated by the major classification societies. The larger established classification societies, Lloyd's, ABS, DNV, BV, RINA, do testing on anchors and anchor types. They rate anchors in relation to a standard high holding power. To receive the rating of high holding power, the anchor must hold a minimum of twice that of the standard Navy stockless anchor of the same weight. Super high holding power. To receive the rating of super high holding power, the anchor must have a holding power of 4 times a standard Navy stockless anchor of the same weight. Most traditional anchors carry the rating of high holding power. Many newer types of anchors designed after the 1980s carry the rating of super high holding power. Classification Society rules allow vessels using SHHP anchors to have an anchor weight 33% lighter than high holding power anchors and 50% lighter than standard Navy stockless anchors. When you are selecting anchors for your boat, remember that there are hundreds of thousands of anchors made by the original manufacturers available in the used market. These older anchors were designed to a quality and a weight distribution standard that ensured that they worked according to the original design. Newer copies of these traditional anchors have no guarantee of steel production quality, proper size proportions, nor proper weight distributions to help the anchors set properly. The potential exists for smaller vessels using new design super high holding power anchors to design anchoring systems that have the ability to secure a significantly larger percentage of the boat's total weight while introducing fewer issues relating to boat stability. Super high holding power anchors offer an important step forward in boat anchoring safety in storm conditions. When working with crew on your boat, you need to have a shared vocabulary relating to anchors and anchoring. This is a Navy stockless anchor. It is traditional to learn the names of the parts of an anchor. Parts of an old-fashioned. The Danforth is a very common anchor, and it is worthwhile to learn the names of the parts of a Danforth anchor as well. Anchors have a number of issues. Their ability to dig down and set, their holding power to weight ratio, and their ability to unclog, shed mud and clay and then reset. Many anchor designs do not perform well on a reset because they clog and become covered in mud, clay and sand. Some types of anchors will not reset if they break loose from the bottom. CQR, pronounced secure, is a plow anchor patented in 1933 by Sir Geoffrey Taylor for pleasure craft. The CQR is rated high holding power and takes a longer distance to dig into the seafloor and does not reset easily. Danforth anchors were designed by Richard Danforth in the early 1940s for use on landing craft. It has good holding in sand and is generally rated high holding power. Fortress makes an aluminum Danforth that in smaller sizes is rated high holding power, while sizes larger than FX37 are rated super high holding power. Bruce or claw anchor was developed by Peter Bruce in the early 1970s for use on the North Sea oil platforms and on large ships. It has a good holding in clay and shell. The Bruce sets well but in smaller sizes has difficulty digging deeply and holding. It is rated high holding power. Delta set fast anchor developed in the 1970s by Simpson Lawrence. The Delta is intended to be an improvement over the CQR by providing quicker setting and flutes with better digging and holding power. The Delta is rated high holding power. Rock anchors designed by Peter Smith and made in New Zealand, were designed to be an improvement over the Delta Set Fast. Rock anchors do set fast and have higher holding power. They are rated super high holding power. Spade anchors. Rated SHHP. The spade anchor sets fast in 2 to 3 anchor lengths and resets well. It can be disassembled for storage. It is rated super high holding power. Mantis anchors. Rated SHHP. The Mantis anchor follows the design of the Rockna. It sets quickly, resets well, has the super high holding power holding rating. It can be disassembled for easy storage. Manson Supreme. Rated SHHP. The Manson Supreme has super high holding power holding ability, sets well and resets well. The Anchor-Rite XL is rated super high holding power. The Anchor-Rite XL has a reputation for doing everything well. It sets in a few anchor lengths. It resets well, and the holes in the anchor help to unclog flukes, making it self-cleaning. The Fortress anchor has the highest holding power to weight ratio of any anchor. All Fortress anchors FX37 and above are rated super high holding power. The typical components of an anchoring system: an anchor of a specified holding capacity, a swivel with the highest safe working load of any component in the anchoring system, chain length with a safe working load greater than the anchor holding capacity, nylon rod with a safe working load greater than the anchor holding capacity, equal to or greater than the safe working load of the chain, acrylic or weights, such as a mushroom anchor, that can be attached to the anchor chain to keep the anchor's shank at 8 degrees or less to parallel to the sea floor. A retrieval line with flow to make it easier to retrieve an anchor by pulling it up by the tipping ring. The retrieval line can create additional problems. The swivel has to have the highest safe working load of any part in the anchor system. The function of the swivel is to keep the chain and rod from getting knotted and kinked, which can unset the anchor, lead to chain failure and weaken the working load on the rod. As the boat rises to the top of a wave crest, the swivel can lock down and stop functioning, introducing twist into the rod, as the boat rises to the top of the wave and falls off in a circular motion to leeward. Chain length recommendations vary from a minimum of 8 feet to 30 feet, or the length of the boat. Some boats use an all-chain rod. The problem with all-chain is the weight in the bow of the boat, which can contribute to rocking and yawing. Nylon rod with a safe working load greater than the anchor holding capacity, equal to or greater than the safe working load of chain, but small enough in diameter to stretch in relation to the weight of the boat and absorb some of the power of the heaving and surge of the waves. Acrylic or weights have been used for thousands of years to improve the holding characteristics of anchors in storm conditions. The objective of adding weights to the chain or rope rod is to keep the shank of the anchor parallel to the sea floor. Typically, on one end of the anchor system, a weak link is used in the anchor locker to easily disconnect the rod, chain and anchor from the boat in an emergency. The other weak link in an anchoring system is the holding power of the anchor, in relation to the working load of all the other components in the anchor system. Retrieval line with a float is used to break an anchor out when it is stuck under a rock or snag. A retrieval line is connected to a tipping ring and pulls the anchor out by the crown. A float and retrieval line can create additional problems by fouling the anchor or anchor line. When we say designing in failure, what we are referring to is designing into the anchoring system a most likely point of failure. You do this so you can reasonably predict what part of your anchoring system is most likely to fail first. The anchor's holding capacity should be the lowest working load within the anchor system you design. The anchor should have a lower holding capacity, the lowest working load, in relation to the safe working load of all the other components within the anchoring system. The piece of equipment that needs to have the highest working load in the system is a swivel. This ensures that the swivel is less likely to lock down and stop functioning under load. The boat captain needs to know the wind holding limits of each of his anchors and monitor the wind speed when at anchor. A Sam L. Morris design Falmouth cutter with a design weight of 7,500 pounds should have the following design horizontal load capacity for each type of anchor. The lunch anchor or stern anchor will have a 900 pounds design horizontal load capacity for winds up to 20 to 25 knots. The working anchor will have a 1,800 pound design horizontal load capacity for winds up to 30 to 35 knots. The storm anchor will have a 3,600 pound design horizontal load capacity for winds up to 45 to 50 knots. Every other component in that anchoring system needs to have a working load capacity greater than the horizontal load capacity of the anchor's intended use as a lunch anchor or working anchor or storm anchor. The objective is to ensure that all the other components in the anchoring system remain functional as the anchor reaches the limits of its holding capacity. Pair anchors and drogues. There are a large number of options in buying a pair anchor or a drogue. Whatever pair anchor or drogue you choose, you need to follow the procedural recommendations provided by the manufacturer for their equipment. Whatever system you decide to invest in, it needs to be simple to deploy and ready to deploy. You need to have practiced deploying the system a number of times at the dock and in various sea state conditions so that you know what to expect. Like an anchor, a pair anchor or a drogue has a number of design factors that make the pair anchor behave in a predictable and functional manner. Since this is safety equipment, not unlike a life raft, I would caution against buying inexpensive copies, because they often have not done the trial and error testing to see what works and what fails, and they have not backed that testing up with clinical trials and accreditation. Some books to consider reading on sea anchors and drogues before you invest in a system. Understanding Sea Anchors and Drogues, Earl Hines. Drag Device Database, Victor Shane. Storm Tactics Handbook, Lynn and Larry Party. Pair Anchoring Pioneering, Zach Smith. Shark Drogue Manual, Zach Smith. Investigating the Use of Drogues, USCG. When coming over a bar, if the drogue slows the boat up too much, or stops the boat, it will likely be hit by a big following wave. If the drogue does not slow the boat down enough, then the boat could pitch, pull or broach. Determine what brand pair anchor you intend to use on your boat. Adapt your deck hardware for that particular type pair anchor and drogue. What system you choose and use will largely be a factor of crew size. If crew fatigue is likely to be an early issue, then the pair anchors and drogues are more important and will need to be deployed sooner rather than later. When buying pair anchors and drogues, the question you have to ask yourself is, in what sea conditions do you expect to use this equipment? A system needs to be designed, built, and practiced before it is used routinely. If the equipment is used for crossing dangerous bars coming into or leaving an inlet, or for holding the boat's bow into the waves, then it will typically be smaller in size. If the equipment is intended to be used offshore for blue water work in extreme weather conditions, then it will need to be larger in size to be effective. The pair anchor, also called a sea anchor, or drift anchor, is used to hold the boat in position, much like a mud anchor. The pair anchor is often used off the bow. It is usually set off the bow in low wave conditions. The pair anchor is a valuable asset in heaving too. In large waves, when the rudder needs to be protected, the pair anchor can be set plus or minus 45 degrees off the bow to hold the boat in position, to minimize drift, to maintain sea room, and to allow the boat to create a slick to calm the sea. The Fiorentino offshore pair anchor is my primary sea anchor because it is constructed heavy-duty and has a swivel with a 28,000-pound safe working load. I carry a backup gale-rider 36 that has an added benefit: it can be used as a pair anchor or a drogue. I have added an extra large swivel to the gale-rider. I have 400 feet of 5/8" braided line, one 12-foot bridle with eyes spliced at each end, and one 25-foot bridle with eyes spliced at each end. I carry 2 mushroom anchors and 100 feet of chain in 20-foot lengths. Example of a Fiorentino pair anchor kit with training materials. An industry standard gale-rider 36 drogue is famous for its versatility. The drogue is attached to the stern of the boat, forward of the rudder, and is used to slow down the boat when running downwind to minimize the possibility of surfing, broaching, yawing or pitch poling. The same holds true for crossing a bar and entering a dangerous inlet. The drogue typically slows the boat by 2 knots, provides greater helm control, assists in minimizing broaching, pitch poling and diving into wave troughs. The drogue can also be used for emergency steering in the event of rudder failure. The heavy-duty Fiorentino Shark drogue has downloadable training manuals and training films. Birksea Brake drogue is a simple and expensive drogue with a good reputation. My primary drogue is the Fiorentino Shark, designed by Zach Smith. My backup drogue is a Birksea Brake. The Fiorentino Shark and Birksea Brake are easily deployed. The bridle for the Shark is tied around heavy-duty deck cleats that have been added for use with the drogue. I would only use the primary winches if I were using the Shark drogue for emergency steering. The Birksea Brake is a lighter-duty drogue and used as my backup. When to deploy a pair anchor? When fatigued, when the crew is exhausted and needs a rest, which is when the likelihood of making mistakes increases. In heavy seas that make it risky to continue running before a storm, or when you do not want the boat to lie a hull that is parallel to the waves. When system failures require the crew's attention, such as rigging and engine trouble, it is used to keep the boat's bow into the wind and waves to make it easier to make repairs. When holding the boat's position, when working to maintain distance offshore or off a lee shore, as weather conditions deteriorate and a safe harbor is out of reach. When you want to heave to and let a weather front pass by. Best of luck in designing a safe and effective anchoring system for your boat. Please let Canada Point Maritime know if this report has been helpful to your understanding of anchors and anchoring, and please give us a thumbs up and share with your boating friends.